हॅलो. हा बोला की. नाही नाही बोला. बोला बोला. So can I start now?
Yes, sir.
Yes, sir.
So today we'll see how to find particular integer. That is Pi. Determination of Pi. Suppose this is the differential equation. F of Py is equal to capital X. This is called linear differential equation. The Pi is given by the reciprocal of the operator 1 upon f of d and operating on capital X. Capital X is the function on the right hand side. So depending on the value of x, there are number of rules for PI. Means actually PI depends on X. And what is X? Any function of X. Okay. So there are three methods of PI. First one, shortcut. Shortcut method. So try to find the PI by shortcut first. And if shortcut method fails, then we apply general method. And third one is method of variation of parameters. Also called MVP. And this method is used only when it is given in the question to solve by MVP. Otherwise, we try to solve the PI by shortcut method and general method. This is shortcut and this is general. So in first method, that is in shortcut method, first one is shortcut. Shortcut method. Rule number one. Capital X. PI depends on capital X. Isn't it? So when X changes or the value of X changes, rule for PI changes. Let us suppose capital X is, which kind of function is this? Do you know the name of this function? This e raised to x is called exponential function. With base e. Base of the function is e. This is exponential function. And PI will be given by PI. PI is equal to 1 upon f of d capital X. What is capital X? Capital X is e raised to x. It is e raised to x. And now the working rule is shortcut means we just by applying the formula find the PI. That is called shortcut method. Isn't it? So the rule is put d is equal to a in f of d. So that is a rule. Very simple rule. Directly replace d by a. A is the coefficient of x. So coefficient of x will be replaced by, or d will be replaced by coefficient of x. So PI will be like this. 1 upon f of a. Put d is equal to a directly, e raised to ax. Provided condition for that is f of a is not equal to 0. So this denominator should not be 0, and that is a condition. If it is 0, then 1 upon 0 will be infinite. But the PI is always finite. And to get the finite PI, provide the condition f of a is not equal to 0. But in failure case, Failure case means when f of a is equal to 0. In failure case, apply the conditions number 1, multiply outside the operator by variable x. Second one, differentiate f of d with respect to d. That is, find f dash d. F dash d means derivative of f of d. And in the third step, put d is equal to a again, this one, in f dash. So these are the 3 steps to be followed in failure case, isn't it? So suppose, so you will get pi in this form. So pi will be like this. Multiply outside by variable x. Then in the derivative f dash d, put d is equal to a, that is, find f dash. You will get f dash a into e raised to x as it is. So that is the pi in failure case. So here also we put the condition f dash a is not equal to 0. If f dash a is equal to 0, again that is a failure case. Repeat the above conditions. Till the pi is finite. So these are the steps to find the pi. To find till the pi is finite. So these are the steps to be used in while finding the pi. Suppose, for example, we will see this example. Suppose we require pi 1 upon t square minus 3d plus 2 operating on e raised to suppose 2x. Okay. So this is the exponential function like e raised to ax. So when it is the e raised to ax, then what is the working rule? The working rule is put d is equal to a in f of d. So here we follow the rule. X is equal to e raised to ax. Put d is equal to a is equal to 2 in f of d. Means in this function put d is equal to 2. So we will get 1 upon 2 square minus 3 into 2 plus 2 operating on e raised to 2x. Then this will be 1 upon 2 square is 4. 4 plus 2, that is 6, minus 6 will be 0, e raised to 2x. So rule fails. Then we follow these 3 steps or the conditions to get the finite pi. So by that conditions or steps, in a failure case, multiply outside the operator by, see, this is the operator. Here is the operator 1 upon d square minus 3d plus 2. So from this, we'll write the pi in failure case as multiply outside the operator by x, then differentiate d square minus 3d plus 2 with respect to d and find f dash d. So derivative of d square like x square is 2d, and derivative of 3d with respect to d is 3, and that of 2 is 0, e raised to 2x is equal to x into 1 upon, again put the value of d, we follow this rule, d is equal to a. What is a? A is 2. So 2 into 2 minus 3 e raised to 2x. So it is x into 1 upon 1 into e raised to 2x. So finally pi is x into e raised to 2x. That is a particular integral. So in the last step, it is free from d, so pi is complete. Clear? Understood this one?
Yes, sir.
Okay. Now, again see, if suppose a particular case of this pi also, one of the type in the pi or exponential function, 1 upon d minus a raised to r operating on e raised to x. Special case. Sometimes we have to apply this formula to find the pi. So the answer will be x raised to r upon r factorial into e raised to x. Sometimes we use this rule to find the pi in failure case. Very simple rule. Remember that if we apply the rule, we have to put d is equal to a. D is equal to a. A minus a will be 0. It will be 0 for how many times? R times. That's why answer is x raised to r upon r factorial e raised to x. So d minus a raised to r is 0 when d is equal to a, isn't it? And it is the repeated, this expression is sometimes known as repeated linear expression. Repeated linear factor d minus. Okay, when it is repeated, when zero factor, we also call this one as zero factor. When this factor is repeated r times, then pi can be obtained by this formula. For example, suppose you are asked to find this one, d minus 2 raised to 4 e raised to 2x. Then is d minus 2 is 0 when d is equal to 2. Is d minus 2 0 when d is equal to 2? It is 0. 2 minus 2 is 0. So rule fails. And remember that this factor, which is 0 for d is equal to 2, is known as repeated linear. Why it is linear? Power of d is 1, multiple of d is also 1. So d minus a with power 1 multiple 1 is called linear. And if the power is r, it is r times repeated linear factor. D minus 2 raised to 4 is 4 times repeated linear factor, d minus 2. So the answer will be like this. What is equivalent to r? If we compare this formula with this problem, r will be 4. It is x raised to 4 upon 4 factorial into e raised to 2x. And that is a pi. That is answer. So this is the way to find the pi, sometimes in failure case. So this factor must be linear and repeated. D minus a raised to r is called repeated linear factor in D, where power of D 1 and multiple of D also 1. See this another example, 1 upon D minus 3 raised to 4 e raised to 3x. Then what is the answer directly? Is it a failure case? When D is equal to 3, 3 minus 3 will be 0. Rule fails. And it is a linear and repeated factor. Linear in the sense power of D is 1, multiple of D also 1. It is a repeated linear factor. 4 times repeated linear factor. The answer will be x raised to 4 upon 4 factorial e raised to 3x. That is the result. So this is the way to apply this formula. So very useful formula for finding the PI. Clear?
Yes, sir.
Okay. Now, in particular, to find PI of exponential function a raised to x, not e raised to x. This is also called exponential function. Base is constant and power is a variable. To find the PI of exponential function a raised to x, put d is equal to log a in f of d. This is the rule for this particular case. And to find PI of a constant term, put d is equal to 0 in f of d. That is it. Suppose, for example, you are asked to solve this PI. 1 upon, suppose, d square plus 1 operating on e raised to 2x plus 2 raised to x and plus 2. Okay. Then in the expression, in the function, there are 3 terms. Term number 1, term number 2, term number 3. These are the different terms, distinct terms, not identical. So write the separate PI of each term. So this is 1 upon d square plus 1 e raised to 2x plus 1 upon number of terms is equal to number of PI, 2 raised to x, 1 upon t square plus 1 operating on 2. This is equal to. So this first PI belongs to the rule number 1. Means directly put d is equal to a. What is the coefficient of x here? Coefficient of x is 2. So put d is equal to 2 in the function directly. It is 2 square plus 1 e raised to 2x plus, in this case, it is the exponential function, but it is in the form of a raised to x. It is 2 raised to x. What is the working rule? Put d is equal to log a. Here also put d is equal to log a. Means log 2. So log 2 square plus 1 operating on 2 raised to x plus, that is the second PI. Now third term is 1 upon d square plus 1 into 2. 2 is the constant term because this term is free from x. That's why it is a constant one. And to find the PI of constant term, directly put d is equal to 0 in the function by this rule. put d is equal to a in f of d, operating on. So it is finally 1 upon 2 square 4 plus 1 is 5 e raised to 2x plus 1 upon as it is log 2 whole square plus 1 operating on 2 raised to x and plus 1 upon 1 operating on 2. That is the final answer. So this is the way to find the pi in rule number 1. This is rule number 1. And now we will see rule number 2. This rule is applicable for these two functions: trigonometric sine in first degree or trigonometric cosine in first degree. So this rule is applicable only for these two functions. And the working rule is for pi is put d square is equal to minus a square in f of d. So that is the only working procedure to find the pi. In case of exponential function e raised to x, d will be replaced by a, or we replace d by a. But in this case, d square, here the rule is for d square, not for d. D square is to be replaced by minus of a square. That means first you decide a, then square it and change the sign. So d square is equal to minus a square. For example, 1 upon d square plus 4d operating on sine 3x or sine 2x suppose. We require this pi. So by this rule, see here, sine 2x is the function equivalent to sine of ax. So for sine ax or cos ax, we always apply this rule. What is the rule? Here what is capital X? Capital X is sine ax or it is sine 2x. So when capital X is sine ax, the rule is put d square is equal to minus a square. This is the rule. Now, if we compare x with if we compare capital X with our function in the problem, see here, you will find that a will be 2. Here a is 2. A square is 4. And put by working rule d square is equal to minus 4. So first decide a, square it, and replace d square by minus of that a square. That is the procedure. So d square is minus 4, but here there is d cube. Just a minute, it is d cube. So d cube will be d square into d. D square is minus 4 into d. It is minus 4d. So d cube will be minus 4. Higher powers can be expressed in terms of d. D cube, d raised to 4, d raised to 5, etc. Then This will be 1 upon, just put the value of d cube. D cube is minus 4d. It is minus 4d plus 4d operating on sine 2x. So minus 4d plus 4d 0. Rule fails. Understood? Clear? Then in failure case, again multiply outside the operator by x and differentiate denominator. Differentiate dq plus 4d with respect to d. What is the derivative of d square? Derivative of d cube is 3d plus derivative of 4d is 4 sine 2x is equal to x into 1 upon 3 into, put the value of d square. D square is minus 4 plus 4 sine 2x. Means it is finally x upon 3 multiplied by minus 4 is 12, minus 12. And minus 12 plus 4 is minus 8 sine 2x. So it is minus x upon 8 sine 2x. And that is the result. So this is the way to apply the rule for trigonometric sine and trigonometric cosine. So the rule is not applicable for tangent or other trigonometric functions, but applicable only for sine and cosine. Remember this one. So in particular case, as a particular one, in particular, when capital X is hyperbolic sine AX or hyperbolic cos AX or cos hyperbolic AX. These are the hyperbolic functions which are identical in all respect with the trigonometric function. The only difference is trigonometric functions are called circular function because they represent the point on the circle. Every point on the circle can be represented by sine function or cosine function. And every point on, this is hyperbola, this one. Every point on the hyperbola is represented by these two functions, sine hyperbolic x or cos. That's why they are known as hyperbolic function. And these trigonometric functions are also known as, another name for this one is circular function. Circular in the sense they represent the point of the circle. And these two functions represent the point of the hyperbola, sorry, ellipse. This is the ellipse, isn't it? So sine, sorry, hyperbolic function, not this is the ellipse, but they represent the point on the hyperbola like this. So every point on the hyperbola can be represented by sine hyperbolic x or cos hyperbolic x, isn't it? So these are the functions. But while finding the pi, see, the working rule for pi is put d square is equal to a square in f of t. So what is the difference in these two rules? In this case, in sine and cosine function, trigonometric and trigonometric question, the working rule is d square is equal to minus a square. But in hyperbolic function, the rule is d square is equal to plus a square. That is the only difference. So that is the rule number 2 to find the pi. And now we will see rule number 3. Rule number 3. Capital X is x raised to m where m belongs to set of positive integers. And this function is called a polynomial function. M must be positive integer. Suppose, for example, you are asked to find this PI. See this, first we see the example, you get the idea about this. X square plus. So now in the function or in the expression x square plus 1, isn't it? The maximum power of x is 2 and 2 is the positive integer, so this is called a polynomial function. So the first step to find the PI is, now we'll see the working rule directly. To find this PI. Step number 1. Express denominator, that is f of d, in the form 1 plus or minus some other function of d by taking lowest degree term common from denominator. So this is the first step. So this PI just somewhat complicated and time consuming problem, time taking problem. So can you tell me the lowest degree term in these three terms? D square 3d minus 8. Lowest degree in the sense power of d. In the first term, power of d is 2. This is 2. So second degree term. Here power of d is 1, first degree term. And here in the last term there is no d, power of d will be 0. So d square plus 3d minus 8. The first one is second degree term, first degree term, and 0 degree term. So which is the lowest degree term here? Either d square or 3d or minus 8. By this first step, we'll take the lowest degree term common from denominator. Lowest degree term common from denominator. The lowest degree term is 8, 0th degree term, minus 8. So if you take minus 8 common from these three, then the last term will be 1 and we write it as first term. It is 1. And for the remaining terms, divide by minus 8. D square plus 3d upon minus 8. So it is minus 8 into 1 minus d square plus 3d divided by 8. So this is the way to simplify denominator. So this denominator can be simplified to this form. So Pi will be like this. 1 upon minus 8 into 1 minus d square plus 3d upon 8. Operating on x square plus 1. Like this. So this is the first step. In the second step, step 2, expand the operator using 1 upon 1 minus t is equal to 1 plus t square plus on up to t raised to m. Here m is, what is m? M is the power of x. Here power of x is 2. So here in our case m is 2. Or 1 upon another formula to expand this by binomial theorem is like this: 1 upon 1 plus t. When it is 1 plus 1 by t or 1 plus t, alternate terms will be negative like this up to t raised to m again, plus or minus. So this is the way to expand. And then in the last step, operate each term of the expansion on x raised to m. So that we will get the pi. Let us see how to operate this one. See this. So by step number 2, keep this 1 upon minus 1 by 8 as it is, and just expand 1 upon 1 minus d square plus 3d by 8 using this formula. 1, here also it is 1. 1 minus t, here it is 1 minus t, this is t. So if we apply, you will get 1, this one. What is equivalent of t? Equivalent of t is d square plus 3d upon 8 plus t square d square plus 3d upon 8 whole square, and plus 1. Beyond that, no need to expand it, because what is m? M is 2. Expand up to t square only. If suppose m is 3, expand up to t cube. M is 4, expand up to t raised to 4, like that. So outside there is what? X square plus. And then simplify this one and then operate it. And here also note that when power of d is more than value of m, the term vanishes. So whenever the power of d is more than power of or the value of m, the term will be 0. That term will be 0. See here, 1. Keep d square as it is, 3d also as it is, divided by 8. But here there is a square. So use binomial formula, a plus b whole square, and expand that one. What is a plus b whole square? A square plus 2ab plus b square. That is a formula, expansion formula. So just use that formula here. And before that, write 8 whole square. That is, what is 8 square? 64. And then use this formula here. D square square plus 2 into d square into 3d and plus 3d square. Bracket close, plus on, and outside there is x. Okay. So after that, keep that 1 upon 8 as it is. So minus 1 by 8 as it is. 1 by 8 into d square plus 3 by 8 into d plus 1 by 64 into d raised to 4. So this term is to be rejected because power of d will be 4 and that is more than 2. That's why I drop this term. No need to write this term. This one. Here also, if we simplify, 2 3s are 6 into d cube. And d cube means power of d is more than 2. So this term also vanishes. So only one term is left, that is the 1 by 64. 3 square is 9 into d square. And operating on x square plus 1. Now, what is the meaning of d of x square plus 1? D of x square plus 1 is derivative of x square plus 1. It is 2x. And d square of x square plus 1 means double derivative of x square plus 1. Derivative of x square plus 1 is 2x. And derivative of 2x is. So after that, so here just write 1 upon 8. 1 multiplied by x square plus 1. Just multiply now. 1 multiplied by x square plus 1 is x square plus 1. Plus 1 by 8. D square of x square plus 1. What is the value of d square of x square plus 1? D square of x square plus 1 is 2. So write here 2. Plus 3 by 8 d of x square plus 1. Derivative of x square plus 1 is 2x. Plus 9 by 64 into derivative, double derivative of x square plus 1, it is 2. And now this entire expression is free from d, and that is the final answer. That is pi. So this is the way to find the pi in failures. So this is somewhat complicated type. Such examples will not be asked in the examination. But remember this one, how to find the pi. In case of which function? It is known as a polynomial function. So capital X is the polynomial function in this case. That means this is the rule number 3 actually. Capital X is x raised to m. M belongs to set of positive integers and the function is called a polynomial function. The first step is express, or you see this one, pi is equal to 1 upon f of d x raised to m is equal to 1 upon express f of d in a binomial form in the form 1 plus or minus some function of d by taking lowest degree term common from denominator x raised to m. Then expand this expression by this binomial theorem 1 upon 1 plus 1 minus t and 1 upon 1 plus t. This is 1 plus t square and plus on up to t raised to m. M is the maximum power of x. This one is 1 minus t plus t square minus t cube, so on. It is plus or minus t raised to m. M being the power of x of the or degree of the polynomial. Expand by these two theorems and operate. That is the rule 1. Okay. And now we'll see rule number 4. Shortcut method, rule number 4. Capital X is e raised to ax into b. So actually what is this? This is product of exponential function and any other function. V is any other function. And when Pi is required, Pi of this product is required, the working rule is like this. Pi is equal to 1 upon f of d e raised to ax into v. So the first thing in this case is shift e raised to ax outside the operator. And replace d by d plus a in f of d. So that is the first step. Means you write this in this form e raised to ax. At the same time, d is replaced by d plus a operating on v. In the second step, new operator 1 upon f of d plus a then operates on v. That is the second step. Very simple. And finally, in a shortcut method, we'll see rule number 5. Capital X is x into v. Again, it is a product. Product of x in first degree. X must be in first degree. And any other function v. So rule is Pi is equal to 1 upon f of d operating on x. So the working procedure or the working rule is like this. It is a formula directly x minus f dash d into 1 upon f of d bracket close into 1 upon f of d operating on. So that is the working procedure for this. So just remember this formula to apply this rule. And the condition for this rule is conditions. The first one, power of x must be 1. And second condition, the multiple outside the bracket 1 upon f of dv should not be a failure case. So first we will have to check the two conditions, then apply this one. So these are the only 5 rules in shortcut method. Clear to all of you? Understood the methods?
Yes, sir.
You will get the clear idea about these rules when we solve the examples. So who recorded the meeting?
Uh,
Chitransh?
I have done it.
Yes, yes, sir. Have you recorded?
Yes, sir.
Okay, then Mr. Ali Sheikh asking for a recording because he left the meeting to prepare the tomorrow's exam.
Okay, sir. I will share it.
Okay. Now,
Okay.
so these are the 5 rules in shortcut method. So just remember the rules, how to apply the rules, isn't it? And if suppose if we cannot find the PI by shortcut method or the given function does not belong to the shortcut one, then we have to use the general method, and that is second one, general method. And in this method, we just use this formula 1 upon d minus a operating on capital X. So here power of d must be 1, multiple of d also 1. 1 multiple power 1, then the formula is in the form of integration e raised to mx. So here it is m, here write minus m, plus m, minus m to plus m, and integral e raised to minus x into x dx. So minus m plus m and again minus 1. So we have to integrate here. So some simple integrals will be there. So using some direct formula from integration, you can solve this. And the second formula, same category, x will be plus m outside e raised to minus mx, and inside the integral e raised to again plus mx. So plus, minus, and then plus x dx. So these are the two formulae in shortcut method when x does not belong to shortcut method. And remember that we can apply shortcut method when capital X is shortcut method. Capital X is e raised to ax, a raised to x, k. Then second one is sin ax or cos ax, sin hyperbolic x, cos hyperbolic x. So that is also yes. Third one, x has to m, where m belongs to positive integer. Then the next x is like this, e raised to ax into b, and fifth one is x into. So these are the standard formula. These are the functions where we can find the PI shortcut. So in all these are the 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the 10 functions where PI can be obtained by shortcut. And if suppose our list does not belong to these functions, then we apply this formula that is called then. So that is all the problem with shortcut. And the method is not applicable. If we fail to apply this method, then use the general method. So that is a criteria. And third one is method of variation of parameters. Also called MVP. So in this method, PI is obtained. And remember, if it is mentioned in the exam or in the problem, then given in the problem, then only apply this method. Means for same like this, solve the differential equation using your VP or method of variation of parameter. Then only follow this third method. So PI is obtained from complementary function. So in complementary function, we have the two constants C1 C2. Then, so by varying that constant, we find the PI. That's what is known as variation of parameter. Method is useful for second order differential equation. This method also used to for which order equation? Second order, not third or fourth order. If let CF is equal to, so can you tell me the CF of this second order? In second order, the CF of the equation contains C1 and C2. And suppose the multiple of C1 is Y1 and multiple C2 is Y2. This is a part of the procedure. Then assume Pi is equal to C1 is replaced by U, unknown function, and C2 is replaced by unknown function V, that is Y2, where C1 and C2 are replaced by unknown functions. U and V respectively. Like this. Then define as a part of procedure, define a determinant delta is equal to y1, y2, y1 dash, y2 dash. That is the derivative. So just solve the determinant, you get delta. Then define u, formula for u, minus integral capital X means right hand side, x y2 upon delta dx, and v integral x into y1 upon delta dx. So for finding u, this u, use the multiple y2, x y2, and for finding v, use the multiple of u, that is y1, x y1 upon delta dx. What is delta? Delta is the value of the determinant y1, y2, y1 dash, y2 dash, and put it in these pi, you will get the solution of the equation. So these are the steps only. From CF write pi. In pi, sorry, while writing pi, C1 will be replaced by unknown function u, C2 will be replaced by unknown function v. We make these replacements, the unknown functions. Then directly define the delta. Delta is y1, y2. Multiple of u is y1, multiple of u is y2. Y1, y2, y1 dash, y2 dash. Solve this sum is not equal to 0. And if it is not equal to 0, then u is minus integral h y2 upon delta dx and v is x y1 upon delta dx. Solving these two integrals, we get the result. This is the way to solve the problem. And remember that in this particular method in variation of parameter, if we require integrals at some stages, we have to use this formula from integration. Integration of sin ax, then integration of cos ax, integration of tan x. Very useful results. Integral of sin is minus 1. It is minus cos ax upon a. And integration of cos is plus sin ax upon a. Always divide the integral by coefficient of x. Coefficient of x and the argument is a divided by a. Integration of tan is log of sec x divided by a. Integration of cot ax dx is log of sin x upon a. Integration of sec ax dx is log of sec ax plus tan ax upon a. And integration of cosec ax dx is log of cosec ax minus cot ax divided by a. So you have to remember these some integrals which are very useful in method of variation of parameters. So these are all the methods of linear differential equation. And from tomorrow, we will start solving examples on this unit or this linear differential equation. Okay, prepare the list of all these rules and formulae, write on one single page and keep the page aside and then solve the problem. So while solving the problem, the page will be with you, formula on that page. Okay.
Okay,
So,
sir.
okay, then so today we stop this session and tomorrow we start at the same time, 8:30 on the same link. Understood?
Okay, sir.
Okay.